All right, so we looked at get, and get has a couple of limitations. The URL, the length of the URL, is limited on what the browsers can encode, right, as part of the URL. I mean, you could potentially encode quite a bit of data and pass it along to an executable function, and pass any data, that any arguments that the function might need. But you're limited by the size and how many characters that the browser will allow you to encode. So that's one limitation. The other one is that the, uh, the, uh, the, the text that gets passed along, right, is in clear text. Right? So any data that you might be sending that it might be private or that is sensitive information, it would be, it would not be right to try to pass this along just in clear text so that anyone in between, right, could intercept that request and see any of this information. So post is a better solution when you want to actually pass data across. Right? That get instead should be delegated to just what the name suggests, just retrieving data that comes back from a server. And instead, if you intend to send data across to the server, instead you would use post. Post has a couple of benefits. It has no limitation other than how much information you can pass actually through the HTTP request. The data is not passed along in URL. Instead, it's passed along as part of the HTTP request in what is called the body, or as if it were an attachment or a document that gets attached to the request. And also, typically, could also be encrypted, right? So that you could exchange secure information using HTTPS for secure communication. So whenever you're passing data and submitting data, typically we would use post instead of get. To use post, you would use the decorator post mapping as opposed to get mapping, as you would expect. So this /API/user would presumably be expecting something that you would pass along as information in the body of the HTTP request. So we need to be able to, just like we did earlier with path param and request param, to be able to parse out pieces of the URL. Here, I mean, we can also pass things as part of the URL, right? But typically most of the data will be just part of the body in the HTTP, and we can retrieve it by using the decorator at request body. At request body by default accepts a JSON object, right? And what it'll try to do is it'll try to map a JSON object with an equivalent Java object of the same schema. So what it'll do is if it finds a username field in the JSON object, it'll try and find a set username in the Java object. If it finds a password attribute in the JSON object, it will try and find a set password in the Java object. Right? What it'll do is it'll instantiate that user instance and then populate it, field for field. Right? It will also do fairly complex transformations. Right? If the JSON object contains field, and then an array of other objects, right? It'll convert the array into whatever the Java expects. If the Java expects an array, it'll convert it into an array. If it expects a list, it'll convert it into a list. Right? So it's pretty powerful. Right? It'll if it has an array of objects, it'll instantiate that array. It'll populate every single object, instantiate every element in the array, and convert it into JSON. Very powerful, right? Conversion between the two worlds. So that's one of the points, that a web service is playing a specific role, right? And it should only play that specific role, right? A web service sits in between two worlds, right? It sits between the streaming world of the HTTP world of ASCII and streaming world, right? And the object world, right? And sits between these worlds and does the conversion back and forth between the Java world, object world, and the streaming world, right? And that's all it should ever do, right? Everything else, like storing into a database and doing some business logic and all that, would be part of some other layer, right? We have to make sure that we divide our concerns, right? That there's a very well-defined set of concerns, and each layer only deals with those concerns, right? So we're talking about the web service layer, right? And that's all it does, right? Transform between these two worlds, and that's the only thing it should ever do, and delegate everything else to other layers, as we'll see next week. So in this case, this one is just echoing back what you sent them, right? If you sent the user with Alice and Wonderland, it instantiates the object, it populates the object in Java, and then it echoes it back. Notice that it's returning the new user, and now does the conversion in reverse. Right, so first it parses from JSON to a Java object, and then it does the inverse, converting the Java object back to JSON and echoes it back to whoever sent it. Okay, so that's the main idea. We'll see a little more as we go, but let's talk about a particular use of this technique.